Grok 4.5 costs 5 times less on output tokens than GPT 5.5, $30 per million versus 6. And if you're running a high-volume coding agent, that gap shows up as real money on every single call. Both models just dropped, and I'm comparing GPT 5.5 versus Grok 4.5 across 5 tests: cost, coding benchmarks, speed, context limits, and deployment. The cheaper model doesn't win every coding benchmark, and which one you pick could decide whether your API bill is manageable or not. My name is Brian, and I'm in these tools 12 hours a day, so you don't have to be. And every number here is traced back to sources both companies actually publish or to independent press reports. If you're calling either model more than a few thousand times a month, the wrong pick could cost you hundreds of dollars you didn't need to spend. Test 1. Cost. The objection I hear all the time is that price differences between frontier models are pretty small and don't really matter. And I get it. When you're prototyping, you're not sending millions of tokens. The day you scale a coding agent to production and you're pushing 10 million output tokens a month. Though, a bad pricing decision shows up fast on your invoice. I looked at the published API pricing for both models, and the gap is wider than I expected. GPT 5.5 runs $5 per million input tokens and $30 per million output. Grok 4.5 is $2 in and $6 out. On top of that, Grok 4.5 publishes a cached input rate of 50 cents per million, and I couldn't find a cached rate for GPT 5.5 at all. Grok 4.5 takes cost, and it's not subtle: 60% cheaper on input, 5 times cheaper on output. The gap came out wider than I thought it would, and press reports even said the price difference is so large that benchmark gaps may not matter much. That puts Grok 4.5 on the board first, 1-0. Test 2. Coding benchmark performance. A solo dev shipping a production feature on a deadline needs to know which model actually resolves real software engineering tasks, not just autocompletes. Get this wrong, and you're burning hours debugging output that looked right but wasn't. The benchmarks here, SWE Bench Pro, Deep SWE, Terminal Bench, are specifically designed to catch that kind of failure. What I found is a genuine split. GPT 5.5 leads on Deep SWE 1.1 with 67% versus Grok's 53%, a 14-point gap on deep engineering tasks. Flip to SWE Bench Pro though, and Grok 4.5 comes out ahead at 64.7 versus GPT 5.5's 58.6. On Terminal Bench and the Coding Agent Index, they're basically tied, 83.4 versus 83.3, and both score 76 on the index. Before you call a winner here, I want to be straight about what these numbers actually mean. GPT 5.5 wins one benchmark, Grok 4.5 wins another, and they tie in 2 more. That's a genuine draw that depends on which type of coding task you're throwing at the model, because Deep SWE and SWE Bench Pro are measuring different things. Coding benchmarks, it's a tie. GPT 5.5's 14-point Deep SWE lead looked like it would pull ahead cleanly, but Grok 4.5, flipping the result on SWE Bench Pro, keeps this one even, and both models being genuinely competitive is kind of wild given the price gap. Score stays at 1 for Grok 4.5, 0 for GPT 5.5, with 1 tied. Test 3. Speed. Picture an agentic loop running 30 sequential calls to generate and verify code, where the model is your bottleneck, at 50 tokens per second versus 100. That's the difference between a 2-minute run and a 4-minute run, multiplied across every workflow you ship, and it compounds fast when you're literally hammering a model all day. Okay, so this is where I have to be straight with you. The data here is messy. Grok 4.5 has a measured figure, 56.5 output tokens per second from artificial analysis, which is actually below the 64 tokens per second median. For GPT 5.5, I couldn't find a directly measured number, and community reports saying it's 2 to 3 times faster than GPT 5.4 aren't a controlled comparison against Grok 4.5. Speed gets no winner. Grok 4.5's 56.5 tokens per second is measured, but below average, GPT 5.5's speed is only community reported, and calling a winner here would just be guessing, so I'm not doing it. That's 2 ties now, and the score stays at Grok 4.5 1, GPT 5.5 0. Alright, so we've got cost and coding benchmarks behind us, but the context and output limits test is still ahead, and that one could completely change which model makes sense for your workflow, because if you're working with large codebases or long documents, the context window test might flip the whole cost calculation. Test 4, context and output limits. 1.1 million tokens is the context window for GPT 5.5, and if you've ever tried to load a large codebase or a long legal doc into a model and hit a truncation error mid-task, you know exactly why this matters. Getting cut off halfway through a refactor because your model ran out of context is a real workflow killer. I looked at the published specs for both models, and this one is pretty clear. GPT 5.5 has a 1.1 million token context window and a published max output of 128,000 tokens. Grok 4.5 sits at 500,000 tokens of context, still large, but less than half of GPT 5.5. And for max output, I couldn't find a published figure from Grok at all. GPT 5.5 takes context and output limits cleanly. 1.1 million versus 500,000 is more than double the room, and I went looking for Grok 4.5's max output number and couldn't find one anywhere, which makes GPT 5.5 the only model here with a clear, documented output ceiling. Score is now tied, 1 each, with 2 tests drawn. Test 5, deployment and modality. The objection I hear from developers switching between providers is that you'll have to rewrite your whole integration when you swap models. And that's a real concern, because if one model uses a completely different SDK, you're looking at engineering time you didn't budget for just to run an A/B test on 2 API endpoints. What I found is that both models are basically built the same way for developers. Both accept text and image input. Both return text. Both support tool calling and structured outputs. And both run on OpenAI-compatible SDKs. GPT 5.5 uses the native OpenAI SDK, and Grok 4.5 uses an OpenAI-compatible one, so swapping between them is pretty much a one-line config change for most setups. I want to be clear though, neither model supports audio or video input per published specs, so if your workflow needs those modalities, both models have the same gap. And the SDK compatibility is close but not identical, so edge cases around streaming or function call formatting could still bite you. Deployment and modality is a tie. The native OpenAI SDK gave GPT 5.5 a potential integration edge on paper, but for the vast majority of developer use cases, both models land in the same place. That wraps the tests. Final score is GPT 5.5 1, Grok 4.5 1, 3 tests tied. So here's where GPT 5.5 clearly wins. Context window, 1.1 million tokens versus Grok's 500,000, which is more than double the room for large codebases or long documents. Deep SWE 1.1, 67% versus 53, a 14-point lead on deep engineering tasks. And max output, 128,000 tokens, with no published equivalent from Grok 4.5. And here's where Grok 4.5 clearly wins. Price, $2 in and $6 out per million tokens versus GPT 5.5's 5 and 30, 60 to 80% cheaper per token. SWE Bench Pro, 64.7% versus 58.6, a 6-point win on the harder coding eval. And Arena A Low, 1,578 versus 1,287, a 291-point crowd-voted lead. Honestly, the data said these two are genuinely different tools for different jobs, which wasn't the clean winner I was looking for. Here's the decision rule. If you need more than 500,000 tokens of context or a documented output ceiling, GPT 5.5 is the only choice. If you're running high-volume coding agents and cost per token is your constraint, Grok 4.5 is 5 times cheaper on output, and at scale, 5 times is not a small number. If you want to see how Grok 4.5 actually performs inside a real coding harness, I've got a video up right now called Grok 4.5 in Cursor, Is It Actually Good?, where I ran it through real tasks and checked whether that price advantage holds up when you're actually using it to ship code.